Please begin by writing down your I can statement, which reads, I can solve compound inequalities and graph them. Now we are going to look at the vocabulary here that says when we consider together two inequalities such as v is greater than 4 and v is less than 18, form a compound inequality. A compound inequality is when we contain the word and. This means that it is only true if it works for both inequalities. The graph where two compounds overlap is called an intersection. So that makes sense. If something is overlapping, that it would be an intersection. So they show us some examples here. That if x is greater than or equal to 3, we graph the first one. And if x is less than 7, then they graph this next one as well. And we're looking, where do those two overlap each other? So they overlap between 3 and 7. So then we can compound them and make it one inequality, such as here. Often you will see it written as 3 is less than or equal to x, which is less than 7, meaning that the answer of x has to be between 3 and 7, including 3. Now we're going to try this next example here. First thing I'm going to do is break apart the inequality. So I will write down -2 is less than x minus 3, and then x minus 3 is less than 4. And we're going to solve them both of those inequalities. So first I'll do the left side one, where I'm going to add 3 to both sides, and we get that 1 is less than or equal to x. So I flip the sign so that I can get x is greater than or equal to 1. Then I repeat that on the other side by adding 3 to both as well, and then I get x is less than 7. Now I'm going to graph both of those on a number line here. So first I graph x is greater than or equal to 1, plot those points. It's a solid dot because it's and equal to, and it's going to the right. And then x is less than 7, so if I graph that, plot my points, open circle going to the left. Now we want to see where do they overlap. So if I draw another line, I can see that if I plot them all here, that my original orange problem, where x is greater than or equal to 1, is plotted, and then x is less than or equal to 7, so I plot them both there. And then I continue to see, okay, they overlap between 1 and 7, so I can say in between they overlap. Hold on. There we go. They overlap, and I keep a solid circle at 1 and an open circle at 7, connecting the two graphs, and then you are done with that problem. Try the two below, and we will go on to example 2 in a second. In this next example, we're going to be doing what's called a union. A union is when we use the word or. So if you ever see they write a problem as x is greater than 2 or x is less than or equal to 1, then we have to have two separate inequalities. These two will not overlap each other. So here if we graph x is greater than 2 in the first line, and then we have x is less than or equal to -1, put them on the same graph, we see that they do not overlap. So in the next example here, we are going to work through and solve to get two inequalities that should not overlap each other, unless there's a special reason, which you will see as we move forward. So first I write down the two problems. I'm solving the first one, and I get -2m plus 7 is less than or equal to 13. So I add 7 to both sides, so -2m is less than or equal to 6. Divide by -2, and I get m and -3, but I know to draw my red arrows here before I can continue on. Then I see that I will have an inequality sign flip to become greater than -3. Then I continue on with the second problem, where I will say that 5m plus 12 is greater than 37. Subtract 12, 5m is greater than 25. Divide by 5, so I get 5m is greater than 5. Now I'm going to graph both of these inequalities, and then we will see how to graph them together afterwards. So first I graph all of my points here, and I'm going to plot just m is greater than -3 first. So I draw a blue circle and, too fast. Then I fill in my circle and draw my arrow to the right. As well, then I go to 5, it's an open circle, and it's going to the right as well. And since they're both going to the right, this blue line that I initially have here will eventually overlap with my green one. So therefore, this is a special case problem that they will overlap, but because they're going in the same direction, not because they are an intersection. They're not intersecting, they're just overlapping each other because they're going the same direction. More times than not, you will see it like they did up here in the example, where they are going in opposite directions. But we just did this special case so you could see it in an example before you see it in your notes. Please try the U-Tries after this, and this concludes the video.